Welcome. Let's look at using SOHCAHTOA in a number of different ways, and that's right-angle trigonometry. So remember, if you haven't seen this before or remember it now, learn it or remember it now, that when you do sine, that's the opposite over the hypotenuse, therefore the O and H. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So using this one here, an angle like that, here is the opposite. Here is the adjacent, and this is the hypotenuse. Notice that if it was an angle here, that would be the opposite side, and this one would be the adjacent, although the hypotenuse stays the same. Well, we are going to use SOHCAHTOA to find the 6 trigonometric functions in this case. So I will give a couple of numbers, in particular 6 and 4. First thing we need to do is determine what the hypotenuse is. And I'm going to do that here, where the radius for the hypotenuse, radius squared, is equal to a squared plus b squared. That's a squared plus b squared is c squared, but in this case, the radius is c. So if the a is 4 and the b is 6, we get that the radius squared is equal to, what, 16 plus 36. So we get a 52. We need r is equal to the square root of 52. Now this would be plus or minus, except that the minus is thrown out because this is a distance, and the distance can only be positive. Well, now, square root of 52 can be broken down as 4 times 13. So that means the actual correct result for the hypotenuse should be 2 root 13. And that's what we have here, 2 root 13. Now, the sine is the opposite over the hypotenuse, and it's also, well, actually, let's put that opposite and hypotenuse. Cosine's adjacent over hypotenuse. Tangent is the opposite over the adjacent, and then the other three are simply the reciprocals. That cosecant is the reciprocal of the sine, so we have the hypotenuse over the opposite, then the hypotenuse over the adjacent, then the adjacent over the opposite. So let's actually put these numbers in and notice what we have to do. For the sine, the opposite for this angle, theta, is 4. And we're going to put that over the 2 root 13 for the hypotenuse. Immediately we see we can cancel the 2 into the 4 to make a 2 above. And that means now that we have 2 root 13, we would be done, except that we are not allowed to have a square root on the bottom of the fraction. So we need to rationalize it. So we get here a result of 2 root 13 over the number 13, because square root of 13 squared is 13. Now let's look at the next one. For the adjacent one here would be the 6 over adjacent. If I can get those letters in place, that's good enough there. Still want to make that look like an A. There, now I did. Close enough. So the adjacent is 6. And notice that the procedure is pretty much the same. That 6 over 2 root 13. So here the 2 goes into the 6, and it leaves 3. So we have 3 over root 13. And when we multiply by the root 13 over 13, we get 3 root 13 over 13. Okay. Now, opposite over adjacent. The opposite in this case was an amount of 4, and the adjacent was an amount of 6 there. Of course, then now that can be reduced. So 2 goes into both of them, giving us a 2 over 3 result. Okay, and I want to move them here so that they're all, the answers are sort of in a line there. Now, the cosecant is simply the reciprocal, and if I come back up here, I could do the reciprocal of this. However, I think that doing it from there would be just fine. In fact, what I'm going to do here is I'm going to put a box around it showing that also is good, except for the square root part. Well, for opposite over hypotenuse over opposite down here, I think it's not necessary to give the final one of this reciprocal, because then you have to do the rationalizing all over again. Instead, take it from here, and we can simply say square root of 13 over 2. And in fact, I'm going to finish marking these in a moment. The hypotenuse over the adjacent. Okay, so we come back up here to cosine, and since it's the reciprocal of it, we would use this. So I will put square root of 13 over 3. Then finally, adjacent over opposite, which is the reciprocal of the tangent, so it's 3 over 2. I didn't keep these all in line vertically with the other ones, but these are at least in line vertically together. So let me go ahead and mark them as correct and final answers for this problem. Now let's take a look at the next one here. Find all of these. And this time I'm going to give the numbers 8 and 5. So that means here doing that 5 squared plus 8 squared will be equal to the radius squared. So that's 25 plus 64, which is an 89. And if I take the square root, I have that the radius is the square root of 89. Now in this case, or hypotenuse here, we are now going to use it in the same normal ways. And I'll first write down what these were: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then the reciprocals: hypotenuse over opposite, hypotenuse over adjacent, and the adjacent over the opposite. So the opposite over the hypotenuse becomes 5 over the square root of 89. Since we have to rationalize it, we're going to get 5 root 89 over 89. And we're going to do the same concept with the next one, only this time it's 8 over square root of 89. And we rationalize it, and we get 8 root 89 over 89. For the opposite over the adjacent, the opposite is 5, and the adjacent is 8, and that's good right there. I won't be able to keep these in order vertically because their other ones took up too much space. Sorry about that. You can still clearly see what they're supposed to be. For the hypotenuse over the opposite, for the cosecant, we put square root of 89 over the opposite, which is 5. And then for the secant, the opposite of the cosine, we would take the square root of 89 and put it over 8. Hypotenuse over the adjacent. And then the adjacent over the opposite would which is 8/5, the reciprocal of the tangent. Now, let's take a look at some of the traditional type of word problems that will help to use state plateau at different times. Okay, let's see what they are. Here on the second page, a certain time of day, the angle of elevation of the sun is 25 degrees. To the nearest foot, find the height of a tree whose shadow is 61 feet long. Now, let's draw this up. Here's the tree. Okay, we need to know what that height is. So when we talk about angle of elevation of the sun, that's the angle from the ground up towards the sun, which is then making that 25 degrees. And the shadow part, if the sun's over here, we end up with sun beams coming this way. And the shadow of the tree then would be this line here, which is 61 feet long. So what we look at is the fact that for this angle 25, we have the opposite over the adjacent. The opposite's across from the summit, and the adjacent is next to it, and it's not the hypotenuse that's involved there. So if we remember that tangent of an angle is the opposite over the adjacent. So we know what the angle is. Ooh, we need to write that with the theta in it. The tangent of an angle is the opposite over the adjacent. So we will do that. We will do that the tangent of 25 degrees is equal to the opposite, which we don't actually know yet, over the 61 feet. We'll put feet back in afterwards since we know the height has to be the feet. So we will multiply that 61 times both. 61 times the tangent of 25 degrees will be equal to the height. And when you put that in the calculator, the tangent of 25 degrees times 61, you get that the height is approximately 28 feet to the nearest foot. Now it's 28.4 feet, but we're going to, in fact, I'll put the 4 first and then cross it out and say that it's 28 feet. There. Okay. Now, next, a practice one of this same type. Height of a tree, 23 feet shadow. And the angle of elevation is 52 degrees. So what we want to know is what's this opposite. And for that, again, we would use tangent. Because we have the opposite, and of course there's the right angle. I need to make sure I put right angles in my pictures. All right. So we have the same type of thing as before, that the tangent of 52 degrees would be the opposite amount, or in this case the height, divided by the adjacent 23 feet. So when we multiply, well, we're going to say we got the h here, we'll multiply this up to here, and multiply both sides by 23, and it cancels out on the right and moves to the left. So we have 23 times, actually don't need that, you can do 23 tangent 52 degrees. And we are supposed to go to the nearest foot. So when we get to it, it's 29.4 feet. So we will simply keep it at 29. Now, this type of problem shows a different way to work out the equation. So let's take a look at what this will be. So we have a 40-foot building, and then we'll make a normal triangle right angle here. The angle of elevation from where you're standing up to the top is 53 degrees. How far away are we? Well, clearly this is opposite and adjacent again, so it's tangent. So we're going to do that the tangent of 53 degrees is equal to the opposite over the adjacent. Now, in this case, notice that the x is in the denominator. Very important issue. Because in the problems before this, we multiplied by the denominator because the x was on top. We could very easily just then do x is equal to, or in that case, h or height was equal to the number times the tangent. In this case, though, we can't work things out with the x in the denominator. We have to get it out of there. So what we'll do, and we'll rewrite this to show that we have to multiply both sides by the x. And what that does is give us that x times the tangent of 53 degrees is equal to 40, but we don't have x by itself, so we have to do another step. And for that step, notice that I'm going to divide by the entire tangent of 53 degrees. So we get that x is equal to 40 divided by the tangent of 53 degrees. And if we put that in the calculator, that's approximately 30.142 and so on. However, this says very clearly to the nearest foot. So that means our answer would be 30 feet. And that would be how far away you are from the building. The next problem is done pretty much the same way. So here it is. Pause the video and do this one yourself and then come back to it and I will be doing it. And you can check your answer. Welcome back. And now in this case, we have a building that's 28 feet. I apologize for my triangle and my building and such being so off kilter. You can see this very clearly what it's supposed to be. 24 degrees. How far away are you from the building? That's this distance. So I'll make it x to the nearest foot. Once again, for this angle 64 degrees, we have an opposite over an adjacent. So we can say that the tangent of 64 degrees is equal to 28 over x. If you did this correctly, it meant multiplying both sides by the x, and we get x. Tangent of 64 degrees is equal to 28. Now we would need to divide both sides by the tangent of 64 degrees. And having done that, we can simply put that in the calculator. And we would get that x is approximately 13.65 and so on, which means we're going to round that to 14 feet, since it says rounded to the nearest foot. So 14 feet is the distance from where you're standing to that building. Now, the next set of problems shows a different technique to use based upon a different thing that's missing. Now, you are standing 75 feet away from the building. So let's set it up with a building, and it tells us how high the building is. 50 feet. You're standing 75 feet. Draw this. And what is the angle of elevation? Let's write that one a little neater here. I'll put that one in red. What is this angle of elevation? Well, once again, though, we have a tangent opposite and adjacent situation. So let's write that the tangent of this angle is equal to the opposite 50 over the adjacent 75. So the both feet cancels. So now with tangent of theta, what to do to find that angle, and this is where we use that -1 key. When you do tangent -1 in the calculator, that gives you back the of an angle. Well, actually, it's not of an angle. You do tangent -1 of the actual tangent. So, or whatever decimal that it comes to, the fraction or decimal. That's the key you could use, which is second and tangent on almost all calculators. So we're going to write this as the tangent -1 of what the actual tangent is. And that will give us back what theta is. So when you put that into the calculator, tangent -1 of 50 over 75, we get back approximately, look carefully at what this one came to, 33.69006. And it says to round to the 10th place. That means we will use the 9, making the 6 into a 7. So we have a 33.7. That is a -3. 33.7 degrees. That is the angle of elevation. So using the -1 key becomes an important factor in some types of problems based upon what it is that's missing. Now let's take a look at this last one, and this one you can practice. Stop the video. When you finish, come back and I will go through it. Welcome back. Well, we're standing 90 feet away from a building. This time I'm going to make my triangle this way just for no reason than for what I want to. Right angle. You're standing 90 feet away from the building. It is 35 feet high. And we don't know what the angle is. What's the angle of elevation? So we do know that the tangent of that angle is 35 feet over 90 feet. Feet cancel. So what we want is to use the -1 key, tangent -1 of that number. Notice 35 over 90 could have been reduced. This is a case where there's no reason to, because it has to be put in the calculator, and the calculator will recognize it for what it is no matter what. This comes to approximately 21.25, almost exactly, I think, 21.25, which means we're going to round it. Since we have to round to the 10th place, we have to make that 21.3 degrees. Don't forget the degree symbol on these. Okay, very important consideration. So notice there are different things being looked for. In this case, it was the angle that was needed to be found on these pages. And then before, it was either the distance or what you would call A, or it was B. Right? Another type of problem could be with hypotenuse, but that in these practice or application problems that doesn't apply for these. So hopefully that helps for recognizing, especially about rationalizing, remembering Precalculus, and then doing these types of what are actually basic trigonometry word problems, but good ones to know so that you are able to always get them correct. Thank you for watching and listening.